लगा दीजिए।
हाँ ही हाँ, वो अभी पहले बोल रहे हैं तो उसके बाद
पहले आप I think instead of I think prefer. Should I ask people to take their seats, Sandeep? Yes. We need to get started. Will you please take your seats? Thank you. I hope you all had a good day so far. Good day. All right. Learned something new. Lots of new things. Made some friends, some enemies. No. Okay. I just want to take a minute to introduce Ankur Puri. Uh, Ankur is a partner at McKinsey and Company and leads a very interesting practice or area within McKinsey. McKinsey a few years ago decided to acquire a organization, right, called Quantum Black. Quantum Black specializes in data science. So uh, I think as a consulting firm, they recognized that data was going to be very important, and therefore, in fact, hired a specialized firm. And Ankur is part of that and leads the practice in India. Within the consulting firm, these things are called practices. That is like a center or a department. But I've known Ankur for I think about 20 years because I left 18 years ago, so it has to be about 20 years ago. We hired Ankur from IIT Delhi. Uh, uh, there he did a computer science integrated master's and bachelor's degree, which was unusual in those days, I think, no? And then came to McKinsey, worked there for 2, 3 years. Ankur has always been very committed to the social sector. So he took some time off and worked with the Public Health Foundation of India, which McKinsey's global managing director, Rajat Gupta, who had also helped me set up ISB, had helped set up PHFI, is a very well-known health foundation in India. And so he worked there for a few years, and then he went and got an MBA from Harvard Business School. So impressive resume, if I may say so. But now the proof will be in the pudding. We'll see how he does today. No, uh, not to put you on the spot or put any pressure on you, but Ankur has been a very good friend, and he always has this offer to me that anytime you call me to Ashoka, I'll come. So today we cashed that chip, and he's here. So welcome, Ankur, and thanks a lot. You know, my data days in McKinsey was very interesting. To Sandeep was saying that McKinsey always had this impression that we had all the data. So I was a part of the steel practice. So in the steel practice, yeah, steel is still a real thing, huh? So in the steel practice, we used to have uh, a model, which was a famous steel model, it used to be called, where we actually had parameters of every blast furnace in the world. The age of the blast furnace, the capacity of the blast furnace, who manufactured it, how, and what was the productivity. And we would use that to help clients when they were looking for operations improvement in their area. So it was a very manual grunt work, but we literally had that data from everywhere in the world. And my first assignment, and then I'll shut up. But consulting is still evolving. So now I'm sure you're using AI to do this. So in my first assignment, I was asked to evaluate whether we should use the a Russian proton rocket to launch small satellites. They were called small sat. The Canadian government had developed technology to do small satellites, small payloads. And so the idea was that they would do small, cheap payloads, and Russia would provide cheap rockets. And together, it would be a very economical way to launch satellites. In those days, communication was just starting mobile. So there was a big thing about satellites being entertainment and communication. But the key thing there was Russia was a black box. cost of these launches are interestingly enough. Because if you lose the satellite on a botched launch, then you lose the money. So you have to insure the satellite before you. Insurance cost depend on the failure rate of the rockets. And so you have to have data on Russian rocket launches to determine what the insurance rate should be. Until then, Russia was behind the iron curtain, so there wasn't enough data. So guess where I got the data? I found a ham operator in Washington, D.C., who used to quietly track through the ham radio network, because he was a rocket enthusiast, track every rocket being launched anywhere in the world. Okay. He had a handwritten register of all rockets launched through the ham radio network. And he knew their password. And that data actually helped solve the problem. By the way, the recommendation was that the Russians had hidden the actual failure rate, and it was so much higher than what was being projected, and the insurance rates made the whole proposition unviable. Very interesting data example, but of course now it's all in the internet, or so you will say. So over to you, Ankur. Thank you.
So one would like to believe. Thank you. When Professor Juneja invited me, I thought the highlight of this year is going to be that I come and speak to you all here. But then you had Pramath introduce me. And I think now talking to you all is my second highlight of the year. Pramath, thank you so much. So thank you for being here. And I know that when I first heard, and I have a very dear friend sitting here, Orko and I worked together for a while, and then he introduced me to Professor Juneja. And then when you said, oh, come and talk to students at this conference, I said, oh, what's going on? He showed me the agenda. I'm like, I think you're calling the wrong Ankur Puri. Okay, like what will I do here? But thank you for taking the risk. Hopefully all of you will stay awake through this and not walk out. So let's see how this goes. I'm Ankur. This is how I feel right now. I feel very joyous coming here and looking at all the wonderful stuff you guys are doing with probability, with the optimization. And I spend all of my time taking all of that knowledge and trying to apply it to real world problems. Most of the time for the private sector, but some of my time also for the sort of public good out of not-for-profit type of work. And since Carol was a mathematician, I thought it's a nice way for me to express how I feel right. I lead a team called Quantum Black. Pramath touched upon it already. And earlier, or maybe half an hour ago, I was sharing that QB basically was a team of small team of people that worked with F1 cars and optimizing F1 strategy in real time. And we acquired them about 10 years ago, and then we sort of grown. And we had our own talent in data science as well, but sort of the teams have all combined now. Today, this team is about 2,500 people. There's a setup in India with about 250 people, data scientists, data engineers, platform architects who all work together to solve real world problems. I have the privilege of leading that team and also then bringing this work to our clients. What you'll hear today is basically stories from the field, and hopefully there'll be something for you to think about at the end of today's session. So firstly, this has, AI and has been like the buzz of town again after about 10 years. I think it was one of the words, ChatGPT was one of the words of the year last year or so. And why is there so much fuss about it? So India's economy right now, roughly $4.27 trillion. The estimated total value that AI can unlock in current terms is, let's say, somewhere around 20 trillion or plus. So there's about 5 India worth of value getting unlocked. And everybody's trying to figure out, how do I get a piece of the pie? This doesn't take into account all the things we don't even know will open up, right? This is only based on economy as we understand it today. So that's why there's so much interest in this. That's why what you do is actually extremely valuable outside. Okay. This is a mix of all sorts of things, but till recently, all the work used to be around basically machine learning in its different form. I'm pretty sure um, you have a more specific way of saying it. So all the work you did with non-linear algorithms is what was very, very precious to the economy. But now with generative AI, there's a whole lot more that has opened up, right? And I believe there's more to come, right? As we start to combine this with technologies, AR, VR, blockchains, it's just I feel like a kid in a candy store, right? You're limited by your imagination and what all you can consume. And hopefully today, a message that you'll take away is just looking at the world with a sense of creativity and innovation on how to solve things with this knowledge that you have and you specializing in, right? So let's start with how executives look at this. Now, most of the time I'll end up talking about the private sector because that's who I end up working with most. But everything I say is more or less applicable to executives, could be leading nonprofit organizations, could be leading public sector organizations. So please keep that in mind. And pardon me for talking more about a few. So it's a very simple world, right? It's a simple world where the way they think about AI is, look, it can do 4 jobs for me. It can describe things. It can predict things. It can prescribe, or as all of you would say, optimize. And now it can generate some stuff, okay? So description is, traditionally, the most sophisticated algorithms we used to use were 2x2s, right? Impact high, low, effort high, low, and the world can be classified, right? When you think about customer segments, probably like age high, low, and like income high, low, and then the world solved like that. But that's not true. That's not how simple the world is. Of course, it's a very powerful setup to get some things done. But suppose you have 1 million customers and you know a lot about them and you want to understand the clusters that they fall in. You can use clustering, right? And then you get a very nuanced understanding of your customers. If you have stores all over the country and you want to understand those stores in clusters, and rather than just saying, oh, North India, South India, large format, small format, you can actually start to classify stores differently. And it completely changes your way of managing those stores, right? So that's how people are using description. It's a simple example, right? Prediction, of course, sort of the bellwether for almost every problem that is getting solved in the industry. Whether you're looking at sort of demand forecasting, whether you're trying to solve for supply chains, whether you're trying to solve for capacity that you need to build out, who's likely to buy what, right? So we are predicting all the time. Prediction or optimization, of course, at the end of the day, everything anyone runs, for profit, not for profit, public sector, is what I have limited resources. How do I get the most out of it? If by design an optimization problem. Now you just can use some maths to help you do that job better, right? So we made 1 million widgets this year. I need to put them in 100,000 stores. How many should I send where so that I get to maximize my sale and minimize my loss in unsold widgets? The optimization problem, right? And it's the problem everyone who produces needs to solve, right? You're sitting here with like the most complex optimization problem in supply chain to solve. And finally, of course, generation. I need to present to this August audience. Can you make me 10 slides? So that's how I got this. I'm joking, okay? But yeah, that's what's happening. So this is how we think about it, because you're talking to people who are extremely busy, who are making decisions all the time, and basically you need to make it accessible, right? So I have my background's in the world of data science as well. I did my master's in computational neuroscience and was trying to build some of these models. But that world seems like truly another century ago, but it isn't. And at the same time, bringing it now to India, to our industry leaders, has been a sheer pleasure. So what do people end up doing, right? What are the most common examples that you will find? So personalization. All the annoying SMSs in your phone, all the ads you do when you do internet search, all the emails you get in your inbox on your email boxes, sorry, all of that is personalization. And if you get into the economics of it, it's very interesting, because if I put a billboard outside Ashoka, I have to believe that so many people saw it, And I had so much sales, right? And it's sort of all sort of effectively praying. But when I start to measure that, look, I'll show something, Sandeep, and then I can tell when you're going to click and buy, people are willing to pay more for that ad. And well, you're going to see an ad anyway, so might as well see an ad for something that may be of interest, right? That's how the people have developed this business. So personalization is a very common example of this. Localization. Then I know Orko did a lot of with us on this one, right? So I've got 100 million biscuits to distribute through the year, biscuit packets. How many do I put in which store? And we can now do this at the level of the specific Kirana store, right? Or you got money to disburse in a city in ATMs. You know, you go and withdraw. We used to, all withdraw money from ATMs mostly. So how much money should you put in each ATM? Because every day that money is lying idle, actually someone's paying interest on it. So localization to me is a different form of personalization, but you're now making decisions at a much more granular level, right? Manufacturing. Pramath, I don't think I ever told you, but the first data science problem we worked on in India and I got to work on was actually blast furnace optimization. And we actually had, this was at a steel plant. It was India's first World Economic Forum lighthouse. World Economic Forum recognizes especially industries on the manufacturing and operations side for successful use of AI and data science. So literally we replaced the database with thousands of runs of that specific blast furnace, and the data from there, including visual data about how orange can you see in the window within the blast furnace. And then you use all of that to say, how do you optimize this machine? Because it's unique, even the same make as probably hundreds of others, but it's operating in this environment with this operator. And so you can actually squeeze in a little more now out of the same blast furnace. So that was actually one of the first things we did in India. So you can optimize yield, you can optimize energy, you can optimize throughput, you can improve quality of so you can reduce defects using what you guys do, right? All of this is extremely valuable. And finally, of course, supply chain, right? Now, supply chains can be manufacturer to point of sale, can be logistics networks, it can be port networks, and shaving off even like a second decimal of wastage is worth a lot at the scale at which these networks operate, right? And it sort of, the maths goes beyond judgment very easily. So you need to use the maths to sort of optimize the most out of this. So that's how industry's been using it all along. And it has delivered a lot of value in the market. So, okay, it depends on the applications. So if we are doing things where the machine gives an output and a human has to interpret before approving a decision, okay? So it could be, for example, when someone's going to say yes or no to a loan application, or something that has with a healthcare diagnosis, then interpretability is very important, right? And we will sacrifice sort of accuracy for it. But if I'm going to show an ad on a web page, I'm just going to look for accuracy. So in that sense, we are doing that. Now, there are cases where for performance issues, out-of-box algorithms may not be fast enough or accurate enough, and we need to squeeze out a little more. And that's where we do need sort of people with solid background in mathematics to work. And a lot of work Orko did was in that space where just sort of taking your open source algorithms, but really changing things at the back end on the basis of strong mathematical understanding will then deliver you that extra edge in the market. Does that answer your question? Yeah. No, sorry. All of this is all nonlinear stuff. So all of this is nonlinear, right? A lot of and depending on the amount of data sets we get, at the very least, you will see use of random forests. We often are using neural networks, but it really depends on how much data you have, right? But very few problems are still getting addressed using linear systems. I don't think there's ever sort of one answer, right? It really depends on the problem you're trying to solve. But it actually doesn't, like, yes, one of the factors is how good are the results between this algorithm versus that algorithm. But actually, a lot of things that determine is how much data do you have? How much time do you have to run the machine? If you're doing like something that will be used once a month, it's okay to let it run for a couple of days and let's squeeze out a little more accuracy. But if I'm doing something in real time and I need an answer then I need to make trade-offs on computation time. So you have to take all of these things into account. So we end up using a whole variety of things, right? Yes.
So for example, let's say a neural network is giving you much more accuracy, but it's like as you said, like black box, like you don't know the like what's happening in the inside, you don't know the weights and biases, and it's like much less interpretable for you guys. Then how do you end up deciding on like when to use let's say an program like algorithm like random forest, and when to just go with like your black box neural networks?
So I think multiple factors. One, as I said, is application and the need for interpretability. So the examples on loan application or medical diagnosis require us to be able to understand things, right? So therefore, you will always use something that's interpretable. And like I gave the example of ad placement, right? It's okay. I don't need to know why I get to see like mountains, as long as I'm likely to click on that, right? In that case, we might do that. So there isn't sort of one factor. We weigh many things. But all of them get used. All of them get used. Okay. I talked about work outside the for-profit world. Sorry. Okay. Yes.
So you mentioned random forest, and I understand that is interpretability aspect of it. What kind of data it is? Is mostly tabular based data, or you have other modalities as well when you look into all of this?
Um, yeah, as long as it is structured data. And sometimes, and that's sort of one of the things that has changed with generative AI. So earlier, I may have unstructured data, let's say like customer feedback. And then someone would convert it into good enough categorical variables, and then we would use it. Okay. So of course we use it. Now with generative AI, the ability to take a long document and take out features out of this is just far better. But yes, it's always been both structured, unstructured. If it is unstructured, we convert it to structured with whatever is possible. Yeah, of course.
How do you, and do you use synthetic data, or do you think this is useful for the work you do?
Everything has its place. So we do find synthetic data useful. We have used it in areas where, for example, we cannot take out the actual data for example, IP reasons. So we ensure that another data set which can mimic it as close as possible to the original is used. Sometimes there's a very important problem where we don't have enough observations. So to some extent, we may, so yeah, augment. Yeah, answer your question? Okay. So I was talking about work outside the for-profit sector. This is um, uh, for a very nice organization that's working with expecting mothers and trying to improve outcomes in places where healthcare facilities are extremely poor. This is Ashok and Antara. So we've been working with them to say how can they use data to support decision making at the last mile. They are working with extremely limited resources. So even if you have an Anganwadi worker, or if you have basically a healthcare worker who's got to cover like 10 villages, right? Today it's a calendar-based system, right? Today I'll go to this village, tomorrow I'll go to that village. But that's not necessarily the optimal answer based on which village has expecting mother that needs a visit. So how do you then help that person build a sort of visit calendar that in the constraint of their time and distances maximizes the care or visits that an expecting mother can get. So what you do can be used everywhere. You just have to look at a problem and say, how can I bring my maths to this and make it better? Yeah. Then, of course, there are all the fun challenges of how will I get the data? How will I make it accessible? How will I make it work at a remote setting with no signal? But once you have the core idea, you'll find answers. Yeah. So I thought I'll give you at least one example from this case. It's been quite rewarding. Um, Now with generative AI, suddenly there's a lot more interest. Okay. We are finding, of course, there's a lot more money behind it again. So this was counted in my 17 to 26 earlier, but this was like the single largest unlock for an executive to use technology with zero capital involved, right? If any of you have a little bit of background in economics, essentially, if earlier in, let's say, 15 years ago, 20 years ago, you had to set up an AI system, you had to buy servers, and then you had to, then start getting GPUs, which now anyway can't get. But then, so you had, if you wanted to do something with data, you had to make all of these investment decisions, which you would be held accountable to. Your feet are on fire. Now with cloud, you can literally get started in 10 minutes, so to speak, right? Earlier, you would still need a team that would be able to use the data to train something. But the way ChatGPT sort of, I guess, mesmerized everyone was that you don't even need to do that. You just open this application and it works. And for many things, it works. And as individuals, there's so much you can like that. But the industry saw a lot of value in this. I'm going to spend a little bit time to talk about this side of things also. At the end of the day, it's the same maths guiding it, right? And I think it's one of the fastest translation of theory to application, right? I think the paper came out in 2017 at NIPSET was presented, and I think 17, right? And 2022 November, the application was unveiled. So of all the things I've tracked, this is probably the fastest translation work you do to real application. So there are 4 types of things people are doing with this where they see a lot of value. First, and I'm hopefully show you a demo, is you can take a lot of information now, and structured, unstructured no longer matters, right? Especially good if it is unstructured, and play in a way that was not possible earlier. Right? That's what we refer to as concision. Then coding and software. At the end of the day, also text in a certain pattern. Ask the system to generate text against something, and something like GitHub has English or sort of your spoken language versus code existing in most languages. So you can learn that very easily and then start to generate text based on prompts. Third is creative content, generate images or generate drafts of slides or documents, whatever. And finally, customer engagement with multimodal, you can talks back to you in a nice way and answers your questions, right? I was talking about the need for creative thinking. It's just gone through the roof now. It's just completely gone through the roof. So let me actually show you something if I project. So, how many of you are aware of management consulting? Management consulting, like my sort of day job, so to speak. Okay. I'm speaking in a room where it's a minority answer for the first time. And I love it. Okay. That's why Alice in Wonderland. Okay. So I think if you had to cluster themes around which jokes are available on the internet, management consulting is near like number 1 or number 2. Okay. So there's a lot to laugh about, but then if you don't have the context, you won't laugh as much. But one of the things is that, we give advice. So we basically talk, but we don't do. But yeah, it's true. But then, of course, like over a couple of decades ago, we started doing things. And then as this became more central, that's why we sort of built this team. And we're like, okay, if you're going to talk about, hey, AI has all of this value, then we have to be able to work with you to do it. And as someone said, you have to have your own medicine. So we tried it. Let me just try and show you what we have done. So when this thing came out in November of 22, in Feb of 23, we had a team start working with this to say, what can we build that's valuable and that's real? This is not a demo, okay? So how do we work? We basically are a global firm. We have several tens of thousands of people who do industry advisory and consulting work. And because of, it's again, large numbers. So we do same type of problems in many places, but then we sort of sit back and say, what did we learn from all this? And we distill our knowledge, right? And about 100 years old now. So there's a lot of documentation that exists. To be specific, there are about 100,000 individual documents. We thought they were all in one database, by the way. It's called No, very creative for knowledge, right? So there were about all the documents, 60,000 or something. But then when we started collecting them, we realized that, every practice, he described practice, right? So industrials is a separate practice, consumer is a practice, banking is a practice. They all had their separate databases, which were not on No. Okay, and then we're like, okay, let's open those up. So eventually we found, I think, about 24 data sets with about 100,000 documents. These documents are everything from scanned typewriter outputs from about 70, 80 years ago to, of course, a lot of PowerPoint. If anybody's made a PowerPoint, which is not made with LaTeX, it is a horror. And Word documents, video interviews, everything, okay? Now, how does our search process work today? Very much like your internet search process. So I'll go and say, how to conduct, let's say, a performance improvement diagnostic at a bank branch. That's it. And then it will do keyword match and it will give me links to some 30, 40 documents. I will open first 3 links. And then I may read some of it because somebody writes really well. So it'll be 10 pages of pure gold. Somebody would have dumped slides and it'll be 100 pages to sift through. And I will get something out of it. I'll look at authors. I'll start to call them. Right? That's how it works. Now, this is what we did with generative AI on this. So think about this as you've taken the same power of ChatGPT, but you focused it on those 100,000 documents. Yeah. It should take all those documents that are relevant. It's not fine-tuned. If you use it technically, it is not fine-tuned. I'll show you the architecture later. It is modular. So there are about 4 models that run at the back for load balancing as well as for experimentation. So when new models come out, we actually use this to test performance in our context. We've tried this with OpenAI suite. We've tried it with all the hyperscaler suites, the Google suite, Anthropic suite, all of them. So yeah, here you have something, okay? So by the way, if you go ask the same question on OpenAI, and if you ask the question in early 23 versus now, maybe you can not go back in a time machine for one of these models, but I'll describe because I've experimented with this. Firstly, you get a reasonably decent answer that people can start working with, okay? And if you do this as a profession, you know how to interpret this very well. But what's interesting is here. So how many of you heard of hallucinations? Yeah. Someone care to tell me what is hallucination? Yeah. Yeah. Basically, it cooks up something which is not in its knowledge base. And as Sam said, it's sort of a feature, not a bug. But now it doesn't work in our profession. It doesn't work in our profession. So what have we done? Our hack for this, because we can't change how the LLM works, is we force the system to return chunks from where it picked up information. So just like, we were inspired by academia. So basically every point has a reference and that reference document is here. So if you really value one of those points, you can go open the document where it came from. The tick marks say that someone has reviewed and approved this. Okay. So if it's in there, then that's sort of as much as we can sort of guarantee that this is okay. It may still be wrong, but at least we are all wrong then. It's not a hallucination, okay? So that's one thing we built in to fix that problem, okay? The other thing was, I actually need to go talk to people who know this stuff. So now I get a list of people who I can reach out to. It's all built in. Right? Now, this is where I think industry application is shifting. which is you take these underlying systems, but you need to build layers on top of it. It is not plug and play, okay? But it's still a lot less effort than trying to build your own FM or LLM, okay? So we now have much lower cost to start doing things. Okay? Depending on what you call typical, but it is an RAG setup, yeah? The reason I think it is not what you might easily see is as part of our IP protection, actually the data and the models are lying in different clouds. And there's a whole encryption system in between to protect our IP. Okay, so that is not so typical, but yes, it is RAG. The reason I show this is it's done two things. One is it has reduced the effort it takes for us to get started on a new problem significantly. But more importantly, it has improved the quality of the answer, because I may have picked the first 2, 3 documents, and they may not have been the best documents, and I may not have sort of synthesized them best way. That's one. But what's fun is we have now extended this. So as I was saying, you know, basically people say we talk, don't do. And the only thing we produce as seen by most of the world is PowerPoint slides. Okay, that's all we produce. So what you will find somewhere, no. So basically now I can convert this into a PowerPoint presentation. I really have no work left. Okay. So and now this is getting into, we are basically building on it. And if you think about this idea of creativity, a lot of large organizations have very valuable information, which is proprietary, which they don't want to put on an internet open space for IP reasons. Now they're like, can you do this for us? So now this is actually a fairly popular thing for us to do, is to help people set up such a system, right? This is now on my phone as well. So if you ask me a fun industry question, I can check. We've now linked it to external data sets. So whether it's sort of data sets that external financial services firms provide, Factiva provides, like just taking all of that and connected it. So now you can actually do, in another version, you can actually do a lot of that kind of what's happening in this market with a lot of quantitative information built in coming out of this. Right? So the idea is that we become less dumb, but there's no evidence. Okay, going back to my presentation. I realized that I'm taking longer than I thought I would take. I'm going to skip some stuff, okay? But later I'm happy to come back and talk again someday. I do want to finish on time, but I also want to talk to you. Now, we talked about messages and all the spam you get in your inboxes. What people have started doing, actually, if you think about that for a minute, okay? How many of us are here? More than 100? Today's algorithms can profile each of us fairly well, okay? Really well. Do the messages in your inboxes, SMS or email, reflect that kind of personalization? They don't. Why? Because building your profile can be done by a machine, writing a message is done by a human. So maybe for 100 people, I might write like 6 messages, because I'll put all the data into some clustering algorithm. It'll tell me there are like 6 or 8 clusters, and then I'll have 6 messages. But now with Gen AI, if I can write the message, I can have a unique one for each of you. In fact, if I want to bug you, I sent you this offer, you haven't looked at it. That can also be unique and personalized. Horror, okay? But that's what's happening now. So this is an example where this classic one we all get. Check out the newest gold credit card that offers personal benefits. Click here to know more, yeah? And now it can get to, hey, insert your name, discover the joys of a black card, perfect for someone who loves indulging in delicacies and exploring the world of cinema. If you've been spending your credit card on food and movies, this is what you'll get. Yeah, if you've been spending that money at some sports store, it will sort of tailor it, right? So now this is what we've gone and now called hyper-personalization, because that bottleneck has gone away. If you think about it from that sense, the machine was doing profiling, humans were doing writing. Now machine is doing profiling, machine is doing writing. Yeah. So All right. Um, I talked about Formula One. This is Formula E, the electric car version. So this was a race that was coming up, and like any good racing car, there are like thousands of parameters, right? And the driver's skill is essentially, or the crew skill is to optimize during a race lap on those thousands of parameters, right? But of course, you have now machine learning systems that can tell you what to do. But as a driver or as a coach for the driver, in a matter of seconds, how do I access that information and make sense of it, right? So you can, of course, build the machine learning piece. That's the stuff that QB people were doing 10 years ago. Now there's a Gen AI piece on top of it, which lets them ask questions in plain English. So now as a team, you can say, what were the differences between the first and the second attempt? What was the pressure on the rear right wheel when we exited turn one? And the system can access all the telemetry, all the predictive models, and answer. So imagine going to your WhatsApp type chat and talking about how your last car race was. Okay, so that's what's happening now. But then, be creative. How do you engage your fans? Let them do the same. So this is an actual product that was built. It was used in a Formula E car. And everyone who bought the ticket to see the race got access to an app through which they could engage with the car. So they could ask in the last lap at that bend what speed you went by. And if you are a sports fan, you'd be hooked. Yeah, I can see lots of nods. Now, suddenly, their sort of stickiness of their customers has gone up. That's pretty valuable for them. Yeah. Now you can think about a whole story around this. So again, I come back to my idea, right? This did not exist. Have any of you used something like this? On your WhatsApp, being able to ask what's happening on your favorite car or what's happening into your favorite sports person? Now imagine if this existed for the Indian cricket team. Yeah? Go build it. Right? Now it's possible. That is something we are exploring, by the way. To be, but just we are limited by our imagination. The tech and its options and all the stuff you guys do with your core sort of theories, the opportunities that exist and how much we've been able to tap, there's a big gap. Okay. How many of you like doom scrolling on places like Amazon and Flipkart to shop? Yeah. Is it really user friendly? Yeah. So the next thing that's coming out already, and increasingly you will see, is now you can chat and buy things. But think about, imagine, do you know personal shopping assistants? Where someone who goes with you counter to counter and helps you shop has gone digital now. Okay. So this is a real world example. We didn't work on this. Most of the work we do is not publicly announced, but we are doing this kind of work a lot now. Where basically you can now chat. This example is I'm going to someone's wedding party, dress should I wear? And there are options of the dress. Okay, suggest I like this one, suggest shoes with it. So you get matching shoes. They're like, oh, but it's on the beach. I can't wear heels. So you get flats. Yeah, it's there. Now these smart mirrors exist. You can go stand in front of the mirror. It'll show you a scroll and it'll superimpose on you. Yeah. So this is the key. This is the key. Because in the old world, humans would have to sit and analyze each product and write description. This did not exist because the cost of building that catalog that you're talking about was too expensive. With generative AI, that cost has gone away. Because for every product, there are dozens of reviews online which have described the product. Perfect to wear at the beach. Wear this with heels. But now you can have a machine read it and write the catalog. That's how this is built. You're absolutely right. Yeah, that's what's happening. That's exactly what's happening. Okay. Goes back to your creativity. Yeah. So I can go on, but let me just sort of move forward. This is, by the way, How many of you, I'll come back to you in a minute. How many of you tried to solve a problem with a business using their online chatbot? Yeah, you have to return a product, something warranty issue. How many of you were like delighted with the experience? Okay, we have one person. Okay, by the law of outliers, okay, it's horrible. But it's changing now. Okay. So by the way, you talked about hallucinations, we talked about IP. I'm now talking about a bank in Europe. Those of you know, is the toughest regulatory environment that exists. So now this is a Gen AI application that a bank has scaled. This is our work. They gave us permission to use their name, so it's here. But basically, this is the old world. You know, it's like all our banking chats, right? It gives you 25 bubbles and then you click. The one you want is not there, right? But you have 25 options, okay? And then you want to talk to someone and they will not let you, right? That's what it's designed for, right? This has gone to chat. And this is a Dutch bank. And like we have English in North India, the Dutch switch between English and Dutch. This system then follows. You're writing in Dutch. If in between you start using English, it will reply in English. When you go back to Dutch, it will reply in Dutch. And no one's written a rule. It's just how it works. Right? And you can, if you think about this now, earlier, how do you measure performance? Simple. I used to get onto this old world chat. I get frustrated and I'd say, I want to talk to an agent. Right? Now with this one, 10% lesser people are going to the agent. And of the satisfaction score, there's 20% higher satisfaction within the chat. Okay. Now, by the way, this for a bank that handles millions of calls every month is massive amount of money. Okay. So, by the way, to be specific, 45 million pounds annualized. Okay. You can fund a lot of good research with that. So, by the way, this is just getting started. We are moving from large language models to small language models. That means things can sit on your phone, things can sit in the car, things can sit in the helmet. Into agentic systems. So not just ask and answer, but get things done. You can execute a lot of things now. Multimodal. So you were talking about image to text and back. So that's obviously now very commonly seen. Chain of thought, very interesting. Let's see how it goes, but at least a new push. And of course, regulation that allows all this to happen safely. So things are just getting started. I realize I'm coming to the end, so I'm going to not go through everything I wanted to say. I want to leave 5 minutes for Q&A at least. So the reality is a lot of excitement, right? More than 90% of the people started pilots in the last couple of years, okay? 90% of organizations, large organizations, think about it as Fortune 1000. But equivalent of that, because this is across the world, it's not just the US, they started trying to use AI. Less than 10% have scaled to even one application. So all of this excitement, all of this money, but very few are scaling. The reason is these things are hard to put together firstly from the engineering side. Okay, just that LLM type thing you saw, the virtual expert Lily I showed you, the LLM is right here, that's it. But then you need to build systems that understand the user's input. You need to have the data ready and accessible. You need to then, of course, query it. But then when the output comes out, how do you look at risk? How do you look at the output in a way that I can use it? There's a lot of engineering that goes around that sort of model, right? And this is true also if you're using machine learning. It's not just for LLMs, right? And by the way, all of that probably sits in one of these boxes. You need data accessible. You need the data to be in a certain format. You need all the feature extraction. You talked about features. You need all the models to exist. If you are going to send that personalized message, someone needs to do the profiling and the sort of propensity models first before you can go into creating a message. And then even after you created everything, you need to find a way to make it available across thousands of maybe parallel cell phone pings and website pings. All of this has to work. All of this has to work with the uncertainties involved in the machine learning piece. Okay. That's just the tech challenge. For some reason, it's not moving ahead. Sorry. This here. In reality, data is a mess everywhere. I'm hoping your research projects don't reflect this, but it's a real mess in the industry. Okay. So a lot of effort, you have to have the commitment to put the data in order for you to do all of this. And for that, you have to believe that the application is going to generate enough money to pay for this effort. Yeah. That's the real world. And that's not all. You need to know what problem to solve. What if you solve the coolest problem that makes no difference to your business? Yeah. We already talked about data and tech, but you also need people to understand this, right? Suppose I'm that insurance company which now has AI models that tell you whether to accept or reject an application. What am I going to think? You're going to take my job away. Yeah. And you're telling me to use this. The real world problem. Someone needs to solve that problem. You need to make them win with this. You need to train them to use this effectively. And then, of course, the operating model. My job changes. Think about that health worker who was used to Monday I go here, Tuesday I go here, Wednesday. Now every day I have to look at this and say, where do I go in the morning? Where do I go in the afternoon? Right? Their jobs changed. Right? With that, all the review systems change, planning systems change, supply systems change, everything changes with that one simple idea. And therefore, you need a lot of effort for change management. You need to get people to explore and believe that this will win, that it's better for everybody. And actually, sometimes it's not. Sometimes people lose jobs. It is true. But in many a case, that's not true. So it's tough. And of course, you have to do it responsibly. I'm not going to spend time on this now. But I want to spend a couple of minutes. We are all sitting here in India. I think it's important to understand what it means for us as a country. Okay? Think about this. When a human takes a call in a call center, it costs 50 rupees a call. Okay, these are real world numbers. When you call that person and say, my shoes were not delivered, or it's the wrong size, blah, blah, blah. That's 50 rupees a call. Okay? By the way, when you go to IVR, that annoying thing that doesn't let you talk to a human, it costs you 10 paisa at most. Okay? Why do you think they do it? Okay? Now, a GenAI chat currently is at about 5. Okay? So those who can afford it will look at this trade-off, and if customer satisfaction matters, you might go here. Yeah? That ING, the bank example I showed you? Yeah. But you are replacing a lot of this here. So you are replacing people who have gone on IVR. So you're actually paying more relative to this. You're paying less here, and that's how the total maths works out. Yeah. So I'm willing to pay more of this if this comes down significantly. That's how the maths works. Very simple maths, but that's what it is. But now, as the cost goes down here, that makes a big difference. Now tell me, will an IVR system ever say, do you feel satisfied? Yeah. With those shoes, do you want to buy track pants? IVR can't do that. GenAI system can. So now the experiment is customer support for problem resolution. And if it's satisfactory, sell. So a cost center becomes a profit center. Business changing. Yeah. Why did I say India here? How many of you know about the IT industry in India and the BPO sector in India? Yeah. We basically manage a lot of IT applications. India's sort of largest companies are in this. BPO sector and call centers employ hundreds and thousands of people. Yeah. What did we just discuss? Calls go down. This is something for us to think about. Yeah. It will hit livelihood of people here. As IT application management goes automated, right? Code writing goes automated. By the way, we're already seeing 25% productivity improvement, which means for work that was done by 100 people can now be done by 75. What happens to those 25 people in a for-profit sector? Yeah. These are real hard things we have to think about. Here's the flip side, pharmaceutical. Do you know about how Indian industry in pharmaceutical is basically, we call it as generics. All the innovation happens in the US or Europe, mainly. And then after a certain period of time, you are allowed to reverse engineer the manufacturing process, and then you can make here at a fraction of the cost. That's our sector. Here's the flip side. Nobel Peace Prize for chemistry went for, yeah. So now you can use AI for drug discovery, which means it will not cost billions of dollars for every new drug. And that's already happening. We're doing this work. You can now discover new drugs at a fraction of the cost, which means our pharma sector can now become an innovator. Yeah, it changes us. Think about media and marketing operations. India was sort of content writing hub for the world. India was animation hub for the world, is. Now, if all the content generation is happening at a tiny fraction of a cost using Gen AI systems, what happens to that sector? No one has answers, but these are questions to deal with. And finally, education. We don't have anywhere close to the number of teachers we need. Forget about good teachers, okay? But if these systems could be geared, just like we have Lily on our knowledge base, could you build that on textbooks and Wikipedia and all the other thing that's available to make knowledge accessible at close to zero cost to everyone? What would that do for India? Yeah. So I sort of selected a little bit of like gloomy ones and a little bit of like bright ones, but these are all questions for us. These are things hopefully you will go and solve. So no, I want people, I'm out of time, so I want to leave this with people. I have a sense, but I think there's much to be done. I have the privilege of working with Niti Ayog in India. And one of my sort of favorite pieces of work right now is to actually deal with these questions. For some old metal music fans, if anybody recognizes, so far so good, so what? But this is for you. This is for you guys. And I would like to take permission for 5 extra minutes to hear from you. What does all of this that I talked about, yeah, mean for you? What does it mean in terms of agenda for research and higher education? Now that you're here, right? What does it mean for collaboration between academia and industry? And what does it mean for you individually in terms of your professional aspiration? And I can see most of you are awake, most of you. Except Pramath, nobody walked out, he's excused. Net, someone's walked in, so I'm fine. And I would love to hear from you, your reflection. There are a few red herrings. So things like, there was this whole ruckus around prompt engineering jobs. Okay? I don't think it's turning into a profession. Right? Imagine having someone, like you tell someone, ask this question, and then someone writes the question. And as you saw in the example I showed you, a lot of that prompt engineering logic is essentially text manipulation that you can put into the system. Right? But for example, if you take the example of animation, we are still away from saying, create a movie that shows like this little girl going through the forest and meeting like Red Riding Hood. I think we are not there yet. Someone still needs to sit between a concept and a system to generate. So the job will evolve, right? A programmer's job is evolving. How many of you write programs, computer programs? Yeah. How many of you are great testers? How many of you take pride in being like a great tester? Not one hand. Okay, one. Thank you. Because now, I know this guy, yeah. Because now, the most important job is testing the code that came out. Because someone else is writing, and someone else is a machine. So I think we have to think about how profiles are changing, because all the changes are happening around existing jobs, right? Building those product catalogs that we saw. Now, system will write something, someone needs to review it. But in all of this, the number of people you need is much lower than the number of people you needed to produce, right? So there is a challenge that's unsolved. But the important thing in my view is we have to be close to all of this application. Only then we will discover what can get industrialized. Right? Otherwise, for example, a lot of the, like, and I hate to say this, but a lot of things started in India because of cost arbitrage. Why did sort of IT management came here? It was because of labor cost arbitrage. And that's gone, right? That's gone. And of course, we've moved on and we are no longer just a labor cost arbitrage, but that was still it is still a significant part of why things come here. So we have to think through this.
So I don't necessarily have like a question. I just wanted to have your take, like your consulting take on this like thing. So you mentioned like more and more we'll get into these things and how like the tremendous amount of possibilities there are in the future. This trend will only increase. But at the same time, like how do you deal with the enormous energy demands of these data centers that are just working on? Because like some of them take the like use the energy equivalent to like literal cities. And I think there was this news which I read, like Gartner sort of like predicted that they'll sort of like have like a 40% reduction in the data centers because of power shortages and all of that. So like how do you deal with the energy demands?
I think there are 2 or 3 patterns you see. One is the more responsible markets are forcing more of like green laws. So incentives for creating green data centers. So centers that use renewable power. One of the big opportunities for India is India has a huge solar farm network, and opening up data centers next to that and compute centers next to that is actually a big opportunity, right? So I think first is, of course, the expansion will happen. And I guess somewhere economics will take over, where if the cost of doing things gets so high, then things will not happen. At the end of the day, it comes down to that 50 rupee versus 5 rupees, right? If the cost of doing this goes back to 50 rupees, it will not happen. I can pass the mic around.
So, like, I wanted to ask, how do you ensure privacy of data? Privacy of data, like data, user data. Yeah.
Uh, so there is a lot you can do. Like I was describing that what we have done, why this was not a typical RAG, is we encrypt data before it goes to an LLM, right? There are like a huge list of things, and if banks are using it in Europe, that means that part has been solved. I'm happy to go through it, but there is a whole list of um, methods available that protect individual privacy with use of these AI systems. Everything from anonymization, encryption, local storage. These are all sort of engineering examples. You don't look convinced. Okay.
Like,
I can take this offline with you.
Yeah.
Yeah.
So does McKinsey do research at the level of not just putting the existing research to serve the purpose of business which can be monetized or taken advantage of at the moment, or like more rigorous research which might not be usable at the moment? And secondly, is there anything related to quantum in the name Quantum Lab, or is just a name?
That is a cool name. But we do have a group of people who are looking at quantum computing in the true sense of the word. We don't have quantum physicists. No, our quantum computing team is not in India. It's mostly in the US. But that's okay. We are a fairly global firm, as in seamless. To your previous question, most of our work is application. Almost all of our work is application. There are in our client's purpose. So whatever the industry needs, we do that. But in terms of theoretical work, I think there's nothing really to say. I'd probably be misrepresenting if I say we do theoretical work here. We do partner in places with academia when that is relevant, right? But most of our work is actually using what's available to solve business problems.
So do you think this tweaking in coming time can also be optimized to a certain degree that the only way to make progress are the only those companies who survive can like contribute in a more original way?
So look, I think
Or there is, other point could be, there could be ample amount of like creative input that goes in creating. I don't have any idea.
no, I'll maybe you catch Orko over tea. One of his favorite examples is one of the world's most successful investment firms, which does original models.
The investment bank have
Yeah.
to-
Yeah, so we don't do that. There's so much money yet to be made with what is available. Where currently we are there. In about 10 years, when this margin is squeezed and we need that, then we might do that as well. But not.
Has has there been some work with working with the government to automate a lot of these law implementation, and like there are cases where you can use two rules to quickly finish the
I know what you're asking.
uh,
I think there's talk about it. So
in
in our
India.
judicial system, yeah, there's in the judicial system there's talk about it.
Okay.
But I think it's not a technology challenge. It's sort of a challenge that goes around beyond. It's sort of how the economics of power works in the system in society. It's not a technology challenge, but yes, there's real conversation around use of technologies like this to expedite at least a section of case law that can be expedited. But I personally think it's going to take some time. I'd be delighted if it happens. It's going to take time.
What are the challenges there then?
Talk about it separately.
Yeah. So you talked about the evolving nature of jobs, right? I'm a radiologist at AIMS Delhi and an AI researcher. So I think we were supposed to be impacted the earliest, as predicted by one of the Nobel laureates of this year. So we have seen how the job has evolved in healthcare.
Yeah.
And gradually, so in general, you know, right? Healthcare is a industry which is very resistant to change.
Yeah.
And it has been like that. But we have seen a gradual shift in radiology AI as well,
Yes.
especially with Gen AI coming, in the sense that initial companies wanted to completely replace the reporting, which did not work out, right? Now we are gradually using Gen AI to write our reports much faster,
Yeah.
in which, and the hyper personalization which it is bringing, in the sense that each doctor has its own way of prescribing and
Yeah.
doing certain diagnosis, that has changed the adoption rate as well. And we are seeing huge increase exponential in the adoption of AI.
Yeah.
But we also see an evolving change in the job profile which we are doing. It's very right that we are taking less amount of time for doing certain jobs. A lot of the work which our typists used to do is almost going down. So that's a hit which that market is taking. But at the same time, it also opens up a lot of the underutilized market in a sense of preventive wellness, which we did not used to do because we had a shortage of radiologists. But now we are gradually doing that whole
Yeah.
body MRI, and AI is helping us in doing that. So I think across all sectors, newer potential opportunities will be coming up.
No, for sure. And I've been close to the healthcare space for about 20 years now. I totally agree. And there have been some interesting experiments with, for example, Watson when it came and tried to do something in oncology. I think the one thing, though, I will say is fundamentally there was a demand supply gap, for example, for trained medical practitioners, no matter which discipline you take. Programming does not have a demand supply gap, right? And I think that's where the problem lies, right? Or call center executives do not have a demand supply gap. That's the problem. But you are right that jobs will evolve, new things will come up, new opportunities will come up.
From us have gone like through the roof. Like one is expected to publish or even have like patents. So my like I wanted some career guidance. Like as data scientists, should we like specialize in every next buzzword like agents, or should we remain like generalized, like
I understand.
exploit versus explore problem?
So I'm going to do one thing here, though. Can I have a show of hands of how many people are interested in this? Because I'll take this outside the room. Okay. maybe I should give a short answer. um, at this moment, I would nudge on the side of being familiar with what's happening. I wouldn't switch to attempt and be an expert, but being familiar, being sort of hands-on explorative, like explore, I think is important. This is changing so fast that for 3 more years, I expect things to just keep changing. Okay. And not everything will stick in terms of where will value come from. But I suspect that if you stay out of this for 3 years, you look at a world which you will not recognize. Yeah. So if you think about how you focus over a period of time in your career, this is a time to not have the blinkers on and maybe shift 5% exploration capacity to 20% exploration capacity. That's what I would say. I'm not in your shoes. I may be wrong, but that's what I see.